Hi students, welcome to Suneel Engineering Academy. I am Suneel Kumar Bandaru. Students, in this Transformers through topic wise MCQ series, already one session completed. This is the second session. If you want previous, you can watch in this YouTube channel. If you have not subscribed this channel, please click on subscribe button to get the notifications. And I have already given my introduction in the previous session, and we have completed some of the question. Let me check up to which we have completed all the basic questions on transformers completed. Yes, up to this one we have completed now. Let us start today's session. Here the question is, which of the following will improve the mutual coupling between primary and secondary circuits? Which improve the mutual coupling. Okay, so when it will be improves the mutual coupling, whenever we have a magnetic core, that must be having low reluctance, high permeability, that is high permeability. Whenever it has high permeability, it can allow flux through it easily. So if you want to say any two windings are mutually coupled or perfectly mutually coupled, it must be coupled with a low reluctance magnetic core. So answer is option D. Okay, coming to the next one, the purpose of conservator in a transformer. What is this conservator? I think all of you know about this conservator. So it is a transformer oil tank. Okay, a small tank that is connected to the transformer. Here, what is the purpose? For example, whenever the transformer is loaded, okay, then current is flowing now. As current is flowing, then losses will be increases. So temperature of the transformer is increases. Whenever the temperature of the transformer is increases, then oil is going to be cool that one. That means oil absorbs the temperature. So we know very well in case of solids, liquids, gases, as temperature increases, they will be expand. So whenever the oil volume expands, it will be enter into this conservator. Okay, it will be enter into the conservator. Okay, in the same way, whenever the load is decreases, temperature is decreases, then oil level is going to be contracts. That means it will comes original value. So then it will be contracts. Okay, so it takes that contraction and expansion. Okay, so this is the conservator tank. This is the conservator. Okay, this is the conservator. So in this conservator, a small box also connected that will contains silica gel. What is the purpose of the silica gel? If any moisture is there in the oil, it will be absorbed that one. Okay, so for that purpose, a small box is connected that may having silica gel. Okay, so to take up contraction and expansion. Coming to the next question, in power transformer, the breather is provided in order to dash. What is that breather? Just now I already said na, a small box that is nothing but can say breather. Okay, so this box is nothing but can say breather. So what is the purpose of this breather? Just now I said na, it absorbs the moisture. So to prevent ingress of moisture with air. Answer is option B. So this is the breather, guys. Okay, if it is the conservator tank, okay, so this will be connected to a small box that is called as breather. It is called as breather. Okay, so this breather contains silica gels. Silica gel. In this silica gel also we are getting the question. Okay, so very important one, this one. So here to prevent the ingress of moisture with air. Coming to the next one, the chemical used in breather is dash. Just now I said, what is the chemical used in breather? All of you, silica gel. Very good. Coming to the next question, students, while watching this session, you have to pause. Whenever I have given a question, you have to click on pause. After that, click on pause and select your answer. After that, check with my answer. Okay, so like that, you have to do this session. The color of fresh silica gel is used in breather of the transformer is dash. It means they are asking the color, which type of color. So generally, the silica gel is in blue color. Okay, it is in blue color. Whenever it absorbs the moisture, after absorbs moisture, okay, it will becomes pink color. It will becomes pink color. Okay, so this is also very important question. The silica gel generally it is in blue color. Whenever it absorbs the moisture, it will becomes pink color. So whenever the breather, the silica gel becomes pink color, we have to change that one again with a new one. Then it can having the absorbing capability. Okay. So answer is blue color. Fresh silica gel, blue color. Sludge formation in transformer oil is due to which of the following? First of all, what is this sludge? I think all of you having aware on this sludge in our real time also. For example, in our bike, we have engine. In that one tank is there, that is oil tank. Okay. So whenever we are running on heavy, running on a bike, a lot of time, then automatically oil will be trying to cool the engine. Then that means oil abstract that heat. Whenever the oil is always abstracts the heat, then it is going to be oxidized. It is going to be oxidized. That means small carbon particles will be formed. So whenever in the oil small carbon particles are added, then it will becomes black thick liquid. It will becomes black thick liquid. That means if you increase the temperature, so you can also observe this one, that is in pakodi center, puri center. Whenever they pour the oil into the bowl, the oil is look like a very fresh and very shining, and it is like a patla. That means very thin. After heating continuously, then if you observe that one, that will becomes black color. Black color. Correct. Why? Because it is going to be oxidized. It is going to be oxidized and it will becomes black color. So whenever it will becomes black thick color liquid, whenever it is a thick, it moves slowly now. It moves slowly. Whenever it moves slowly, it cannot absorb the heat perfectly. So its nature is decreases. Okay. So that's why we have to change the new oil. So that's why for every 2000 kilometers, 3000 kilometers running, we are changing our oil in the engines. Okay. So in all type of machines which having the oil, we have to change frequently. Why? Because that will becomes oxidized due to high temperature. Okay. So oxidation of transformer oil. Oxidation of transformer oil. Okay. So sludge formation in transformer oil is due to high temperature. Due to that, oxidation of transformer. Coming to the next question, centrifugal methods of reconditioning transformer oil is effective for removal of dash. So for example, if the transformer oil is going to be formed sludge, then it will become thick liquid, then it cannot absorb the heat very well. In that case, generally we have to change the oil. Okay, for example, if the budget is not in our hands, then we can also use one more method, centrifugal method. So due to the centrifugal method, that means due to this centrifugal method, then all the solid particles will be separated. That is, all the carbon particles will be separated. Whenever the solid particles are separated, then again the oil will be clean and clear. Okay, so it can be removes the solid impurities. Okay, carbon impurities. Oil is provided in an oil filled transformer for which purpose? For which purpose? So generally oil is used as both the cooling and insulation. Transformer cooling and insulation oil must be dash. Just now I have given the oil must have moves faster, correct? Moves faster. That means less opposition to move. Okay, that means it must having low viscosity. Low viscosity. So it must having low viscosity. If it has low viscosity, then can move faster. Can move faster. Most of the students having doubt on viscosity. Sir, what is the viscosity? Viscosity is nothing but just like a friction, guys. We know the friction in the solid now. That means if any particle want to move, there is always one opposing force is there. That opposing force is nothing but friction. Here, in case of liquids, we have the viscosity. That is nothing but viscosity is nothing but which opposes the fluid motion. Just like a resistance, just like a friction. Okay, opposing quantity, nothing but. Okay, so whenever it is having low viscosity, it can move faster. Then it can absorb the heat very well. It can absorb the heat very well. Okay, so low viscosity. The type of oil used in transformer cooling and insulation. Which type of oil? Olive oil, coconut oil, palm oil, mineral oil. Okay, so we are not using these cooking oils. We are using mineral oils. Okay, like paraffin, like that. Right? Okay, the oil must be very thin. Then only it can move faster. Okay, so that means it must having low viscosity. The dielectric strength of transformer oil should be dash. How many questions only from a small topic about transformer oil? Okay, so from these sessions you can get this type of topic wise MCQs, guys. Okay, a small topic, lot of MCQs, so you can get the concept and also you can get a very good practice. The dielectric strength of transformer should be 30 kilovolt. Should be 30 kilovolt. Okay. According to Lenz law, the induced EMF sets up a current in which direction? We know very well about this Lenz law. EMF is equal to minus N d pi by dt. Okay, so minus is Lenz law. So that is nothing but opposition. That is nothing but you can say direction opposite to the cause producing it. What is the cause? Change in flux is the cause. And what is the effect? Due to the change in flux, EMF is induced. Okay, EMF is induced. So the effect always opposes the cause. Okay, and the direction is opposite. The angle between applied voltage and EMF in transformer. The angle between applied voltage and EMF. It is always having 180 degrees. Okay, so let us take this one. All of you listen carefully. It is a very important one. So first of all, you have given the supply. Okay, so this is considered as supply waveform V1. Whenever you have given the supply transformer, it is having winding now. Winding is nothing but just like an inductor. So inductor current lagging 90 degrees. So after 90 degrees generally the current is flowing, correct? after 90 degrees the current is flowing. Let us take one more color. After 90 degrees the current is flowing. Okay, so and current and flux both are in phase. Always whenever the current is flowing, then at the same time flux also produces phi 1. Whenever this flux pi changes, an EMF will be produced. That means it takes another 90 degrees lagging. After flux, the EMF will be induced. Okay, so that means here the angle between this EMF and voltage is total from this point to this point of cycle, that is 90 degrees. Sorry, 180 degrees. Angle between voltage and EMF is 180 degrees. Answer is 180. And in the same way, the angle between voltage and primary current 90 degrees. Angle between current and flux 0 degrees. And also angle between current and EMF 90 degrees. Angle between this flux and EMF 90 degrees. Okay, so E is equal to minus n d pi by dt. So whenever the flux changes, then only EMF is produced. Okay, so then angle between the flux and EMF is generally 90 degrees. Okay, flux produces, whenever it changes, then only EMF produces. So it is late by 90 degrees. Okay, so this lagging leading is very easy, guys. Which comes first is leading, which comes late lagging. First of all, you have given voltage. After that, current is flowing. So current is late. So late by 90 degrees. After the whenever the current is flowing at the same time, flux also produces. So both are in phase. Both are in phase. After 90 degrees, then EMF will be produced. So total angle between voltage and EMF is 90 plus 90, 180 degrees. Okay. The total flux at the end of the long permanent bar magnet is 100 into 10 power minus 4 Weber. The end of it, this magnet is withdrawn through a 1000-ton coil in 1 by 20 seconds. The induced EMF in the coil is dash. Very easy question, guys. First of all, pause this video, try yourself. After that, check with my answer. Okay. So we know EMF equation method. EMF formulas minus n d pi by dt, and E is equal to BLV sin theta. Okay, and also EMF equation 4.44 pi Fn, that is also there. Here what are the quantities are given? Flux given and number of turns given, time given. Flux, turns, time. So this equation is suitable. Okay, so number of turns. Minus is just it opposes the change in flux. Okay, so no need to take in magnitude. Number of turns 1000, change in flux 100 into 10 power minus 4 Weber by time 1 by 2. Okay, this 20 also comes to the numerator. Here 3 zeros, 4 zeros, 10 power minus 4 cancelled out. 20 comes to the numerator, 20 into 10, 200. So answer is option. So the answer is option. Okay, very easy question. Coming to the next one, guys. A 250 kVA, 11,000 volts bar, 400 volts and 50 single phase transformer has 80 turns on the secondary. What is the maximum value of the flux? What is the maximum value of the flux? Just now I said we have the three equations. E is equal to minus n d pi by dt, E is equal to BLV sin theta, and also EMF in the transformer is equal to 4.44 pi Fn or pi Ft, pi Fn or pi Ft. Flux is the maximum flux generally. N is the number of turns. So here turns given, voltages are given. So voltages given, and what is the maximum flux? So let us try secondary. They have given secondary turn. So take the secondary EMF 4.44 pi F N2. Okay. So the E2 they have given. This is the E1. This is the E2. 400. 4.44 into flux. We have to find out, and frequency 50 hertz and number of turns. Okay, number of turns. So just calculate 50 into 8, 400. So this one cancelled out. Then pi m is equal to 4.44 into 10, that is 44. 1 by 44. So that is nothing but almost you will get 22.5 milliweber. So the answer is options. Okay. Coming to the next question. A very simple question. Just we have to substitute the values and get the answer. If R2 is the resistance of secondary winding of a transformer and K is the transformation ratio, K I have already given N2 by N1 or V2 by V1 or I1 by I2. Okay. The equivalent secondary resistance referred to primary. Secondary to primary. That means it is the secondary resistance is referred to primary. So secondary resistance means R2. It is referred to primary means we have to make it as dash SP. Secondary to primary. R2 dash is equal to R2 by K square. In the same way, primary to secondary is the primary resistance, that is primary R1. Whenever coming to secondary, we have to make it as dash, then R1 into K square. Okay, for this, you can simply remember by small trick. A small trick is that is secondary to primary divided by K square na. So secondary to primary divided by K square, SPD, simply remember as SP dosha, special dosha. Okay, special dosha. If you want, you can eat. Okay, and you can also send to me. So SP dosha, secondary to primary division. The same way, primary to secondary, PS multiplication, PS, flux setting multiplier. We know very well flux setting multiplier. So PSM, primary to secondary multiplication. These are the two tricks to remember. So remember any one trick, other one is no need, just opposite. Okay. So if you want to get idea, then that is very simple, guys. Whenever the secondary resistance is there na, R2, this will comes to the primary means primary already R1 is there. So this R2 comes here. We have to make it as R2 dash. Okay. So in this current flowing is I1. In this secondary the current flowing is I2. If resistance is in the secondary or in the primary, whatever it may be, due to that resistance, the power losses are same. Correct? If you have any one resistance, due to that power losses are same now. So for example, if it is in the primary side, primary current I1 square into R2 dash is equal to, if there is resistance in secondary side, secondary current I2 square into R2, correct? So losses are always same. If you want to get R2 dash, send this I1 to this side, then I2 square by I1 square into R2 na. So I2 square by I1 square. I2 by I1 is equal to 1 by K. So R2 into 1 by K whole square. That means R2 by K square. Got it? R2 by K square. This is the real explanation. This is our short trick. Okay. So this is not copied one. This trick is not copied one, guys. This is our own trick. Okay. So R2 by K square. So no need to do all this in the examination. So whenever you are getting the question in the examination, secondary to primary, SP, those are division R2 by K square. Okay, that is a simple one. A 10 ohm resistive load is to be impedance matched by a transformer to a source with 6250 ohms of internal resistance. The ratio of primary to secondary turns. Primary to secondary turns N1 by N, that is nothing but turns ratio. Don't confuse, guys. N1 by N2 turns ratio. A. N2 by N1 transformation ratio. Okay. Okay. So here they have given a internal resistance or source resistance 6250, load 10 ohms load is there. Okay, 10 ohms load is there. Okay, so here they are asking this load is to be impedance matched by a transformer with a source. So if it has to be matched with a source means this resistance has to be replaced here now. This resistance has to be replaced here. Whenever it is comes to here, that means if you can consider it is the R2, if the R2 comes to here, then it will becomes R2 dash. And we know very well, just now we have discussed secondary to primary. What is that? SP dosa division. R2 by K square. So this R2 is value is 10 by K square. K is nothing but transformation ratio N2 by N1. Okay, that means we can make it as K is equal to 1 by A na, 1 by A, or A is equal to 1 by K. So 1 by K square means you can make it as A square. A square. Okay, so this value is nothing but 10A square. This has to be matched with the source. What is the maximum transformation theorem or matching theorem? Whenever the load resistance is equal to source resistance. Okay, that is R2 dash is equal to RS 6250. Then A is equal to 25. So the answer is B. So ratio of primary to secondary is 20. Once again, guys, a very simple question. Don't feel it is a difficult. Just they are asking ratio of primary to secondary. Primary to secondary is nothing but turns ratio. We want to find out A. Okay, they have given one load resistance. It has to be matched with the source resistance. Here it is in the primary side, load, that is load always in the secondary side, correct? So that means we have to transform this secondary to primary. Then R2 will becomes R2 dash. And if you want to match this, R2 dash is equal to RS. Okay, R2 dash is equal to R2 by K square, 10A square, that is equal to 20. Okay, clear? Coming to the next question. Leakage flux in a transformer occurs because of that. Leakage flux in a transformer occurs because of that. Because of air is not a good insulator. Whenever the air is good insulator, then there is no flow of the flux through the air. Whenever there is no flux flow through the air, then there is no leakage flux. What is meant by leakage flux? If it is a transformer core, here we have the windings. Okay, whenever the current flowing through this one, flux will be produced. Most of the flux will be flow and it will be reached to the secondary. But some of the flux may be leaks here and here. This flux is nothing but can say leakage flux. It is associated with only one winding, not two windings. Okay. So this flux is nothing but leakage flux. Why leakage flux we are getting? Here air is also allowing some of the flux to flow through it. So that's why we are getting the leakage flux. Okay, if the air is not allowing, then all will be flow through the magnetic core. Okay. For example, if you provide some security guards here, if anyone is trying to leak, then that security guard will beat, then that person will be no chance to leak in any other place. He has to be, must be flow through the line only. But here there is no security persons. Okay, so that's why some of the flux may be leaks also. Because of air is not a good magnetic insulator. In the air we have oxygen, is there na? Oxygen is a paramagnetic material. Very important question. Oxygen is a paramagnetic material. So paramagnetic material, it will have a little bit permeability. So it may allows a little bit flux through it. So that's why we are getting the leakage flux. Okay. We are getting the leakage flux. Coming to the next one. A transformer cannot rise or lower the voltage of DC supply. We know very well, we have already discussed in the previous, because of Faraday's laws may not valid. Why? Because we know very well E is equal to minus n d pi by dt. If d pi by dt, if for DC supply, d pi by dt is 0. Right? Whenever the flux is not changes, its value is 0. Whenever the 0, there is no EMF. There is no EMF means Faraday's law is not valid. Okay, so that means Faraday said that if you want to produce the EMF, then the flux must be having time varying. If it is a static device, in a running device, it is a constant flux, that is time invariant flux, and any one has to be rotate. Between the two components, one has to be rotated, then only flux cutting action takes place. Okay, so here answer is option C. Coming to the next question, if AC supply to the transformer is replaced by DC, then there is no change in flux, no EMF. Whenever there is no opposition, then lot of current will be flow to the primary, then primary winding is going to be burned. So the answer is option yes. Okay. Okay, students, in the next session we will discuss the remaining questions. Okay, so if you have not subscribed this channel, please click on subscribe button, and also please share this information to all your friends. With your encouragement only, I can take more classes. Okay, so please support me and encourage me with your likes, comments, and also by sharing. Thank you so much, guys.